Hi students, now we are going to see exercise 1.3 proving irrationality of irrational numbers. So we are going to prove the irrationality of irrational numbers. So first of all, what do you mean by rational numbers? What do you mean by rational numbers? Rational number is nothing but if a number can be expressed as p by q provided the denominator should not be equal to 0 and p and q must be integers. Okay, so this is the condition for rational numbers. What do you mean by irrational numbers? Irrational numbers is if a number which cannot be expressed in the form p by q. Okay, I cannot write it in the form of p by q. That we call that to be as irrational numbers. For example, the square root of all the prime numbers will be the irrational numbers. Okay, square root of all the prime numbers, say square root of 2, square root of 3, square root of 5. So all these are irrational numbers. Now we are going to see the theorem. If p is a prime, p divides a square, where a is any number, then p divides a also. Here if I consider a prime number, say p. So if p is a prime number and this p if it divides a square where a is any number, then p divides a also. That is, if you just consider a prime number, say 2. So this 2, it divides 100, isn't it? 2 divides 100. 2 divides 100. So if 2 divides 100 means this implies 2 divides square root of 100. Square root of 100 is nothing but 10. So if p divides a square, then p divides a also. That is, if p divides a square, so I can write this 100 as 10 square. If p divides a square, then p divides a also. That is, p divides its square root, that is 10. Is it clear? If p divides a square, then p divides a. This is the theorem. This is the meaning for the statement of this theorem. First of all, let us see how to prove the square root of 2 is irrational number. Just now I had told you square root of all the prime numbers is irrational number, isn't it? So now I am going to show that square root of 2 is an irrational number. Square root of 2 is an irrational number. So we are going to solve this by the method of contradiction. Solution by the method of contradiction. By the method of contradiction, we are going to assume that root 2 is rational. Okay, so by the method of contradiction, I am going to assume that this root 2 is rational. What happens if root 2 is rational? So let us assume root 2 as rational. Okay, so let us assume root 2 as rational. So if I assume that root 2 is rational number, then I can write root 2 as root 2 is equal to p by q format, provided q should not be equal to 0 and this p and q are co-prime numbers. Okay, so where p and q are co-prime numbers. So if I can able to write a number as rational number, then I can write it as in the form of p by q. This q should not be equal to 0 and this both p and q should be co-prime numbers. So co-prime in the sense that, what do you mean by co-prime? Co-prime means the HCF is equal to 1. That is, the HCF p and q have HCF is equal to 1. So let us assume this as some 1, equation 1. Okay, now I am having root 2 is equal to p by q, isn't it? Root 2 is equal to p divided by q. Now I am just going to cross multiply this. So when I cross multiply, we get root 2q is equal to p. Mark this to be as equation 2. Now going to square on both sides. So squaring on both sides. Squaring on both sides. So we get square root of 2q the whole square is equal to p square. So this is nothing but 2q square, that is square root of 2 the whole square. Square root of 2 square is nothing but square root of 2 square is nothing but square and root get cancelled, we get 2. So 2q square is equal to p square. So q square is equal to p square divided by 2. So q square is equal to p square by 2. So what is the previous theorem? That is, just now we had seen, no, If P is a prime number, if P divides A square, then P divides A also. So I am going to apply that concept. So if 2 divides P square, this implies 2 divides P also. 2 divides P also. So that we can write P by 2 is equal to some C. Let us say P by 2 is equal to some C. Now we can write P is equal to 2C. Is this concept clear? 2 divides P square means 2 divides P, because just now we had proved the theorem. If A divides P square, then A divides P also, no? So that concept only I am going to apply. 2 divides P square in the sense that 2 divides P. So 2 divides P, that is P by 2, I will get some answer, isn't it? So that answer I am just assuming it as C. So now P is equal to 2C. Mark this to be as equation 3. So actually consider this second equation. What is the second equation? Second equation implies root 2q is equal to P, isn't it? So I'm going to apply this P value. I'm just going to substitute the second equation in the third equation. So that is, in the place of P, I'm just going to substitute root 2q. Okay, so third equation நம்ம கண்டுபிடிச்சிருக்கோம் இல்லையா, third equation P is equal to 2C into இப்போ என்ன பண்ண போறோம்னா இந்த second equation நம்ம find out பண்ணிருக்கோம் இல்லையா, P உடைய value root 2q ண்டு அதை நம்ம இதை substitute பண்ண போறோம். So we are just going to substitute the P value, that is substitute the P value in third equation. So we will get in the place of P, I'm going to substitute root 2q is equal to 2C. Root 2q is equal to 2C. Now I am going to square on both sides. So when I square on both sides, so when I use to square on both sides, we get 2q square is equal to 4c square. Okay, so when I square on both sides, root 2 square is nothing but 2q square is equal to 4c square. So this implies q square is equal to 4c square by 2. So we will get q square is equal to 2c square. So this implies q square divided by 2 is equal to c square. So what does this means? This means that if already we had said that if A divides P square, then A divides P also. Here 2 divides q square, so this implies 2 divides q square. So this implies 2 divides q also. 2 divides q. Okay, so 2 divides q. Having 2 divides q, isn't it? That is q divided by 2 is equal to, so I will get some answer, isn't it? When I am dividing, we will get some answer. So let us assume that as some D, say. So this implies q is equal to 2D. Now actually we have in the third equation P is equal to 2C, isn't it? That is third equation. P is equal to 2C. Let us mark this to be as fourth equation. Q is equal to 2D. So we are having P is equal to 2C and Q is equal to 2D, isn't it? So what does this implies? This implies that 2 is a common factor. 2 is the common factor. 2 is a common factor. Okay, so we are telling that 2 is a common factor, but consider the first equation. What is the first equation? In the first equation we are telling that HCF is equal to 1, but we are having by equation 1 HCF is equal to 1, but this implies our assumption is wrong. So we have a wrong assumption. So what our assumption is root 2 is rational, but this is wrong. So therefore root 2 is irrational. So we conclude that root 2 is irrational. The next example is prove root 3 is irrational. So we have to show that root 3 is irrational. This is also the same method as the previous sum. Okay, we are going to prove by the method of contradiction. That is, we are just going to assume that root 3 is rational. After that we will be just concluding that root 3 is an irrational number. Okay, solution by the method of contradiction. by the method of contradiction, we are assuming that let root 3 be rational. Okay, so let us assume that root 3 is rational. Then we can have root 3 is equal to somewhat p by q. This q should not be equal to 0, and what we will say, p and q are co-primes. P and q are co-primes. So this implies p and q have HCF to be as 1. So co-prime means their HCF to be as 1. Mark this to be as equation 1. So we are having root 3 is equal to p by q. So just cross multiply. We get q root 3 is equal to p. Mark this to be as equation 2. Now let us square on both sides. So when I square on both sides, squaring on both sides. So when I used to squaring on both sides, we get q root 3 the whole square is equal to p square. So q square into 3 is equal to p square. So p square is equal to 3q square. So q square is equal to p square divided by 3. So q square is equal to p square divided by 3. We are having this result, isn't it? So what does this implies? This implies that 3 divides p square means then 3 divides p also. This is by the theorem. So this implies that 3 divides p square implies 3 divides p also. So this, so when I'm just dividing, we will get some answers, isn't it? P by 3 is equal to c. Say, so let us assume it as some c. So this implies p is equal to 3c. So I'm just assuming p value to be as 3c. Now actually in second equation, consider the second equation. In the second equation we are having the p value to be as q root 3, isn't it? I'm just going to substitute the second equation in this third equation. Substitute 2 in 3. So we get, so the value of p is q root 3. So in the place of p, q root 3 is equal to 3c. So just squaring on both sides. When I used to square on both sides, we get q root 3 whole square is equal to 3c the whole square. So this implies q square into 3 is equal to 9c square. So 3 ones are 3 3s are 9. So this implies q square is equal to 3c square. So this implies q square divided by 3 is equal to c square. Now what can I say? So I can say that 3 divides q square. It means 3 divides q also. 3 divides q also. Okay. So 3 divides q also. So we can say that q divided by 3, that is q by 3 is equal to d. Say. Okay. So this implies q is equal to 3d. Now let us mark this to be as fourth equation. I'm just going to compare these two statements. That is, we are having p is equal to 3c and q is equal to 3d. That is, this is the equation, third equation, and this is fourth equation, isn't it? So this implies that 3 is the HCF. Okay, 3 is the HCF, that is the common factor. 3 is a common factor for these two statements. But what is our assumption? Our assumption is that HCF is 1 because p and q are co-primes. But HCF is equal to 1. This is wrong. This is wrong. But HCF is equal to 1 by our assumption. So this is wrong. So I can write HCF of PQ is equal to 3. Okay, HCF of PQ is equal to 3, but already we are having that our assumption is HCF is 1. So this is wrong because of our assumption. This is wrong because of our wrong assumption. Because of a wrong assumption. Therefore, root 3 is irrational. So, we just conclude that root 3 to be as irrational. exercise 1.3, the first sum, prove that root 5 is irrational number. So in already we had seen the two example sums, isn't it? So based on the same concept, we are going to prove that root 5 is also an irrational number. That is, square root under a prime number is a irrational number. So square root keda prime number, square root of prime number வந்து irrational தான். So அதுதான் நம்ம வந்து இப்போ prove பண்ண போறோம். So as usual, by the method of contradiction, we are going to prove. Solution by the method of contradiction. By the method of contradiction, let us assume root 5 is rational number. So root 5 is rational number in the sense that I can write root 5 to be as p divided by q. Q should not be equal to 0. That is, p by q, it should be a simplified form. Okay, p by q, it should be a simplified form, so that only we can say that p and q are co-prime numbers. So what even be a simplified form? If I consider 2 by 4, I can even simplify this as 1 divided by 2. This 1 by 2 is simplified form. I cannot further simplify it anymore. So now for this, the HCF is 1. Okay, the common factor is 1. So that we call that to be a simplified form. So here, this root 5, this can be written in the form p by q, where q should not be equal to 0, and p and q are co-prime numbers. That is, the HCF is equal to 1, where p and q are co-prime and HCF is equal to 1. Now, just cross multiply. We get root 5q is equal to p. Mark this to be as equation 1. Just squaring on both sides. So, when I square on both sides, we get root 5q the whole square is equal to p square. That is, 5q square is equal to p square. So this implies q square is equal to p square by 5. So what does this implies? This implies that 5 divides p square. 5 divides p square means 5 divides p also. 5 divides p also. So this implies that p by 5 is equal to c. So when I divide, we will get some answers. So let us assume it as some c. P by 5 is equal to c. Say. Now this implies p is equal to 5c. Mark this to be as equation 2. Okay, already this is equation 1 and this one is equation 2. Now just substitute first equation in second equation. Substitute 1 in 2. So what is the value of p? P value is root 5q. I am just going to substitute the value. So p value is root 5q is equal to 5c. So once again, we just square on both sides. Squaring on both sides. So we get 5q square is equal to 25c square. So q square is equal to 25 divided by 5c square. So q square is equal to 5c square. So this implies q square divided by 5 is equal to c square. So what does this implies? This implies that 5 divides q square. 5 divides q square means 5 divides q also. That is, q by 5 is equal to d, say. So this implies q is equal to 5d. Mark this to be as equation 3. Now consider the second equation and third equation. What is the second equation? P is equal to 5c, and the third equation is q is equal to 5d. So second equation is p is equal to 5c, and the third equation is q is equal to 5d. So what does this implies? This implies that the HCF is equal to 5. But this is wrong. This is wrong because HCF is 1. Because our assumption is HCF is 1. So this is wrong because of our assumption. So this is a contradiction. That is, this is a contradiction to our assumption that root 5 is rational. So root 5 rational நம்ம எடுத்துக்கிட்டதால தான் அது தப்பா இருக்கு. Okay, therefore root 5 is irrational number. Therefore we say that root 5 is irrational. This is the answer for sum number 1. Sum number 2, prove that 3 plus 2 root 5 is irrational number. So we have to prove that 3 plus 2 root 5 is irrational number. So let us assume that by the same method, by the method of contradiction. Okay, by the method of contradiction, let us assume 3 plus 2 root 5 is rational. Okay, so therefore 3 plus 2 root 5, so if I assume it as rational, then we can say that 3 plus 2 root 5 as p by q. So this q should not be equal to 0. P and q are co-primes, that is p and q are integers. Okay, so p and q are co-primes, that is HCF of p and q is equal to 1. So we are having 3 plus 2 root 5 is equal to p by q. So 2 root 5 is equal to p by q. This plus 3, when it goes to the other side, we get minus 3. So this is equal to p minus, just cross multiply, we get when I just cross multiply, we get p minus 3q divided by q. 2 root 5 is equal to p minus 3q divided by q. So here root 5 is equal to p minus 3q divided by 2q. Okay, now you just see p and q are integers. This is an integer. So if I subtract an integer with integer, we get an integer only, and this is also an integer. Okay, so here as we already said that p and q are co-primes, and p and q both are integers. P and q are integers. So an integer minus integer will get an integer only, and here also this q is an integer. When a number is multiplied with an integer, we get integer only. So integer divided by integer. So it is of the form p by q format. So it is of the form p by q format in the sense that we can say that it is a rational number. But actually root 5 is irrational number. Just now we had proved, isn't it? Root 5 is irrational number. So now you can see irrational equal to rational. This is a contradiction. This is a contradiction. Therefore, this contradicts to our assumption. This contradicts to our assumption that 3 plus 2 root 5 is rational. Therefore, our assumption is wrong. Our assumption is wrong. Therefore 3 plus 2 root 5 is irrational number. So this is answer for sum number 2. Third question, prove that the following are irrationals. The first subdivision is 1 divided by root 2. So let us assume that 1 by root 2 as rational. Let 1 by root 2 as rational. Okay, so let us assume that 1 by root 2 as rational number. So 1 divided by root 2 as rational. So 1 divided by root 2 as rational means we can write it in the form p by q, where this q should not be equal to 0, and the p and q both are integers, and their HCF is equal to 1, isn't it? Now I can write, we can write it as q divided, that is I am going to reciprocate this. So p by q is equal to root 2 by 1. Okay, I am just going to reciprocate, taking reciprocal. Okay, so when I just reciprocate it, we get q divided by p is equal to root 2 by 1. So q divided by p is equal to root 2. So this is of the form, anyway it is of the form p by q, some fraction part. Anyway this both are not equal to 0. So this is rational. Okay, this is rational. Actually what is root 2? Root 2, we already proved that root 2 is irrational. So root 2 is irrational. So this is a contradiction. So rational cannot be equal to irrational. So this contradicts this contradiction. This contradiction has arisen due to our wrong assumption. Therefore 1 divided by root 2 is irrational number. So this is answer for first subdivision. Second subdivision, 7 root 5. So we have to prove that once again the 7 root 5 to be as irrational number. So let us going to assume by the method of contradiction that let us assume 7 root 5 as rational number. So when I apply 7 root 5 as rational number, we can write it in the form p by q. This q should not be equal to 0. So root 5 is equal to p divided by 7q. So here this is of the form p by q. So p by q, I can say that it is a rational number. Root 5 already we had proved that it is an irrational number. Okay, so irrational is equal to rational is not possible. This is a contradiction to our assumption. Therefore 7 root 5 is irrational number. Okay. Third subdivision, 6 plus root 2. So let us assume that 6 plus root 2 as rational. Okay, let 6 plus root 2 as rational. So if I assume this, we can write 6 plus root 2 as 6 plus root 2 is equal to p by q. So root 2 is equal to p by q. When plus 6 when it comes here, this becomes minus 6. So root 2 p, just cross multiply, we get p minus 6q divided by q. So this is irrational number because already we had proved root 2 is irrational number. This is of the form p by q. So it is rational number. This is a contradiction to our assumption. Therefore 6 plus root 2 is irrational number. So this is answer for sum number 3, third subdivision.